I know, it's not the end of the world. So, probability. We talked a little bit about this earlier. We talked about, last week we talked about theoretical versus experimental probabilities. You know, in theory, what would happen versus what happens in real life. We're going to look a little bit at both of that. I don't know if we'll get to all of it. Like Cullen, the magician. Cullen, ready?
I got 2 hearts.
Takes so long, you just gotta go.
I don't know. If you get it right, you feel like you have to get it right.
Or choose suit. Collect suit.
What you want?
Want you want.
Wow, I don't know how to write.
What you want. And
So what you want? No, nothing?
What you want?
Beastie Boys? So what you want?
Beastie Boys?
What you want over
I took it for a little bit. I don't know where it went now.
over total possible? Probability?
Props to you.
I'll just go with my 10 of spades again. You got it right.
Yeah, 9 of spades was close.
Oh.
So what you want to happen over the total possible. It's you guys have all done this before. Like Cullen the magician, the probability he was able to get the right card. Well, how many total cards are in a deck? 52. What was the probability of him picking the one? So he did fairly well. Right? He did fairly well on that one. So it's probability that I'm going to flip over a heart.
13 and 52, which is...
So the probability of...
Yeah, 1/4.
The probability of a heart.
1/4.
1/4. Good. You guys are already simplifying the fraction. So you're looking at it, there's 13 out of 52, which means it's 1/4. Thanks. Flip card. Tell me what it is. Let's see if we're right. It's a heart. We have a heart. Get it?
Okay.
All right.
Okay. So this was difficult. Remember, it's just all this. Number of outcomes over total outcomes. You guys have all seen this in the past. One of the things I want you to remember, what is, if the probability equals 0, what does that mean? No chance. Not gonna happen.
Chance that Caleb's going to get in a basketball game.
Well, I heard he played once. Now, the probability, if it equals 1,
You're going to do it.
it's going to happen. For example, what is the probability? You usually see it written like this, P, then you put the possible thing that you're looking for inside. What's the probability of homework?
1 out of
100 of me.
Tell you the truth today, so not once.
One. It's 1. Can your probabilities ever be greater than 1?
No.
No. Can probably ever be less than 0? No. So it's always between 0 and 1. You have a 6, oh, they use the word die. I was surprised. I thought it was number 2. 6-sided die, numbered 1 through 6. What would be the probability of rolling a 4?
1 to 6.
All right. So the probability of a 4 would be 1 out of 6. What about the probability of odd?
Half.
Good. Half. Probability of less than 7.
1.
Bless you.
What if like Magic Place just lands on
Don't
the
talk to
side
me.
and
We're talking about normal. There's always one.
Like, you never know.
That's true.
Stuff can happen.
I don't know if it lands on.
Sometimes it's not possible or convenient to make this stuff happen. You have then the experimental probabilities. Now, this happens a lot in surveys. You guys have probably done this before. Just to kind of look at a table here. If I'm looking at a table, they're giving me all these data points, and let's say this is this is age of a lot of people. Okay. It was. If you're 24 and under, there are 94,000 of you. Between 25 and 44, there's 83 and change. 55, and so on and so on. So if you wanted to figure out if the person is at least 45 years old, that means they can be 45 or older or 45 or younger. Or older. Okay? Because that's the bottom end. Which means if I'm looking at the theory or the experimental probability here is, well, how many people would be over how many people there are? Pretty sure you've done that before, right? I wasn't really.
Wait, I have a question.
Yes, ma'am.
Would they ever ask like 55, maybe younger?
No, because they'll have to use something in the data. Okay, you'll have to have something in the data, otherwise it's just gonna all go all crazy. All right. So I'm gonna leave that one, but I do want to spend some time on geometric probability. Do you remember what geometric probability was?
No.
Well, what's it? Geometric probability is the area, you want the probability of the favorable area divided by the probability of the, or excuse me, not the probability, it's the area of the favorable region divided by total region. So if I wanted to see what the probability of hitting the bullseye here is, last time I checked, that bullseye looks like a, well, yes, there's a 3 in it. It looks like a circle.
Yeah.
Okay? How do you find the area of a circle? Very good. Even though pi.
Oh.
So the probability of me hitting the circle. What?
I really threw me off guard.
What don't you believe happening?
You're probably.
Yes, I am.
What's the chance that you hit your forehead on the board?
So the probability of getting, you might want to move over a little bit because I'm not very good at this. What is the favorable region? That's the radius, so what's the area?
Sit. Oh.
I
didn't.
So the whoa! So the bullseye,
I was waiting for what's the radius and what's the diameter.
that is a 3. 3 squared is 9 pi. All right, 3 plus 1 plus 2 plus 1 plus 2 plus 3.
I got this real quick. 12. 12.
12. What's 12 squared?
144.
So 9 pi over 12 pi. When you simplify that out, it's 9 over 12, which is some number.
0.0625.
Yep. All right, see if I'm any good at this. Pardon me. You're still worried me. I'm in front of you.
That's close.
That was in.
Problem is it's on the inside.
Oh!
Is that the closest you've got?
You don't even flinch.
What's that music?
What is that from?
No, ice cream.
Generic arcade.
It's an arcade game. I forget what it was. It's Pac-Man.
Yeah, I was just gonna say that.
Yeah, it's the start of Pac-Man. Then it goes
Okay, I was gonna say that, but
I can hit the wall over there. I just wanted to, it just gave me a reason to take the bow and arrow out today.
I knew you did that. That's smart work.
Area stuff, a lot of times, the one thing that you guys are gonna forget kind of looks like what I have drawn up on the board over there. You know what that's from?
The multiplication chart?
Multiplication chart. That's funny as heck. Let's see. I'm trying to see what you remember. Do you remember how to find the area of a regular polygon?
It's A.
Yep.
Wait, so.
Perimeter apple. Hey, look at that. It's this right here. It's just so convenient.
Yeah.
The geometry's working on it right now.
they had a trend one on the ACT and I just blanked so bad.
What's that?
Area.
Well, we throw a little bit in here. So let's say in this case, I want to find the geometric probability I'm going to land in the shaded region. When you're looking at this, in order to find shaded region, you find the area of the large, subtract the area of the small. Okay? Now, what is the overall large shape here? It's a circle. Okay? How do you find the area of a circle? It's pi r squared. Well, I don't have the r here, do I?
Oh.
So, looking at the shape, what's the shape on the inside? It's a hexagon. You guys vaguely recall anything about the hexagon? They're all, these are, when you split them in, these become 60s, which means the radius is 16. Remember that?
Yeah.
Yes.
So now, what does the apothem do to the side?
Splits it in half.
Splits it in half. So that means if this is an 8, what would be the height there? It's that thing that happens to be also on the board. 8 and 3.
Yeah.
You get the special triangles, things like
I
that.
have to say that, and for some reason my mind went.
So the area of the circle. Whoa!
Caleb, do this.
16 squared pi. Subtract
Wait.
area of the circle. I'm subtracting out the hexagon. Subtract out 1/2 the perimeter. Well, the sides are 16, so it would be 16 times 6. And our apothem is 8√3. So that's going to give us the whole, the area of the shaded region. And then what do I have to divide all that by for the overall area? What's the large shape? They divide all that by 16 squared pi again.
Oh, right. Oh, we're finding probabilities though.
Yeah.
Oh, yeah.
So we're trying to find the probability of landing in the little sections.
So, what is it?
I don't know. Less than 1, greater than 0.
Why do you switch your
I'm trying to find the shaded region, so I'm taking large shapes, subtracting small.
Oh.
And that gives me the area. That gives me my variable.
shape.
Yeah. Okay. This is little stuff here that I know you've seen, but it's been a while, so I just want to kind of touch on it. It's very delicate. I don't want people to break it. So you get some crummy number here. You know, you can press 1 and it doesn't show anymore.
I did it wrong. I don't know.
Yes, you did something wrong. You probably didn't throw parentheses around the second half. So 0.5 times 16 times 8 times 8√3. So my numerator, I just got a negative number, that didn't work. Oh, I times it by 8, that's why, duh. 6 sides. Let's type something good. The apple would be 8√3. Perimeter is 16 times 6. 16 squared pi, it's going to be 6 pi. I must have typed something in wrong.
No thanks, she's the one that needs to be. You got that kind of thing.
What'd you get? Because I ran.
I didn't know what you had tonight, so I'm feeling like my answer.
I don't know what I got. I got 74. I don't know.
All right, I got 139 and change for that, for the top. You gotta make sure you put parentheses around stuff here. I'm getting my answer at, anybody else get this? Point 173?
I got
Yeah. What's that? The formula is 1/2 perimeter times the half. The 16 times 6, each side is 16. There's 6 of them.
I'm still wow.
Let me give you a couple of these for tonight here. Yeah, right. I knew that was going to happen. What is this? 719. Let's do. We'll come back to probability stuff tomorrow. We'll start with that tomorrow. Let's do 12 through 29. 719, 12 through 29.
Not even?
All, yeah. 719, 12 through 29. So this is 12-3. That'll get you through that. They'll get you through one table of theoretical probability or experimental probability, and then we'll start off with the 12 through 29. We'll start off more with the geometric stuff tomorrow. No big deal. We got plenty of time.
I'm sorry, what is wrong?
Really?
Oh, yeah.
It's tennis spades. That's what it is. Jeez. I wonder if I can hit color.
It's not hot or anything.
It's both.
I'm not ready for you.
And I don't want to. Oh, that's a great idea.
Oh, yeah. Shoot, kid.
Oh, yeah, it's real funny. Can I snap it?
Hurry up, man.
Oh, so close.
They don't stick very well. I need to get a Nerf. The Nerf guns have the suction cups, right? It gives you an excuse to buy a Nerf gun. My kids don't have those yet. Fighting the urge to buy them. Otherwise, if my TV's going to run out of darts.
Can we get one more shot?
I would, yes.
Can I see you take one more shot?
His nose.
You're ready.
She passes back.
I should give you a sound effect.
You do nothing.
Sweet.
Yay.
Just remember, I need a video of you shooting my face.
Well, you do realize that nobody would have. It's just fun to.
I was gonna put out my Snapchat story. Everyone.